Today we are doing the second set of notes of Chapter 1, and we're going to be talking about simplifying expressions. So we're going to go over some definitions to begin. The first definition is variables. Variables are simply any letter or symbol that represents an unknown. So you can use any letter. Typically we use X, Y, Z, and so forth, but you can use any letter of the alphabet or a symbol. Then we're going to talk about terms. So terms are the number of variables or constants that you see. So it's the number of variables, constants. Your constants are numbers without variables. So if, for example, it says x plus 5, 5 would be the constant. In order for terms to be considered like terms, it has to be the same variable and it has to have the same exponent. Today, again, we're talking about expressions. So expressions are different than equations because equations have equal signs and equations imply that you are solving. Today, we are simply simplifying, meaning combining like terms where possible. No solving for today. So here the directions say simplify the expression. We're going to have to do distributive property. We'll distribute the 2 to the two terms inside the parenthesis. Notice we're not distributing it to the 6 because the 6 is outside of the parentheses. When I distribute this, I get 10y minus 4 plus 6. So the variable that we have is y. The number of terms I have right now are 3. The number of terms that are considered like terms are the 4 and the 6. So when I put those together, negative 4 plus 6 gives me plus 2, and my answer is 10y plus 2. 10y and 2 are not like terms because they don't have the same variable, so that is as far as we can go. For the next one, we are distributing a negative 1 per se, so if you want to write a little 1 in here, so that way you know we're distributing a negative 1. So I have 3y minus 4y minus 6x. Again, going over the terminology, right now I have 3 terms, 2 are considered like terms. So when I put them together, I get negative y minus 6x. So that's it for simplifying. Now we're going to talk about evaluating. So evaluating is I'm giving you a numerical value that represents each variable. So you're going to substitute them in. So here, everywhere I see A, I put 3. Everywhere I see B, I use negative 1. We typically use parentheses when we evaluate. So here I have 3 minus 2 times the quantity of negative 1 plus 3 times negative 1. After you substitute it in with the parentheses, then we decide if I really need them. So for the first term, the 3, I do not, so I can drop them. For these middle 2 terms, I am doing negative 2 times a negative 1, so that will become plus 2. And then for the second grouping, the third grouping of values, I'm doing 3 times negative 1, which would be a negative 3. You don't really have to write plus negative 3. You could just write minus 3 if you wanted. And then we go left to right, so 3 plus 2 is 5, minus 3, final answer is 2. Some of you might have been saying in your head that you recognize that the 3 and the negative 3 would cancel out when I add them together, and that also just puts you directly at the answer of positive 2. That's fine as well. Fourth example, we're going over some exponent rules. So here, again, we are evaluating this at a 3. Notice I put the 3 in the parentheses, but the negative and the squared remain outside of the parentheses. And then here, again, I have 3 plus 1. So we're going to use our PEMDAS, which says we do parentheses first. So inside this first grouping of parentheses, 3 plus 1 will leave me with a 4. and I'm going to put that minus 2 out front. I'm going to kind of condense this into one step. So as far as the exponent rules, then I go to the squared. I'm squaring the 3, not the negative. So this negative is still out front, and 3 squared is 9. PEMDAS, so we did parentheses, I did my exponents, so the next thing would be multiplication. So multiplication is right here between the negative 2 and the 4. So I have negative 9 minus 8. And now we're just simply combining these two, so negative 9 minus 8 will leave us with negative 17 for our final answer. The last thing that we're going to do today is apply this concept of combining like terms to a geometric shape. So perimeter means you add up all the outsides, so we're going to go around and add up all the sides. When you look at this picture, you should notice that one side is missing. Remember, when you have shapes, opposite sides are congruent. So the missing measurement is across the way, is that if the left side is A, the right side also has to be A. So that's something that you should jot down. And now we're going to go through and just combine our like terms. So I'm going to kind of use this highlighter here. So I have A, 2A, and another A. So when I add those 4 up, or those 3 terms up, I get a total of 4A. So that's 1A, 1A, 2A. That gives me the 4A. Then the next, I have B, B, and B. So when I add those up, I get 3B. And now the last two are my fractions. So I have 2A minus B over 2 plus 2A minus B over 2. Because I have common denominators already, I can add the numerators. So the tops are going to get combined. So I'm going to write just one fraction here. And in the top, I'm going to have 4A minus 2B. And again, I took this top here and I added it with the other top there. And that's how I got the 4A minus 2B. I'm just going to drop down that 4A plus 3B because we didn't touch that yet. Now, in terms of my fraction, we can divide this out. So the 4A divided by 2 would become 2A, and 2B divided by 2 becomes negative B. So I just kind of reduced that fraction. So let me just circle that in red. I just reduced these two values, and that's how we got this here down. And then we're going to combine like terms. So the 4A and the 2A will combine to be 6A, and 3B minus B will leave me with 2B. So I kind of went over there for the final answer. And that's all for the second set of notes.